A very good morning to all of you. Today we will do a numerical problem on the topic we have studied in the last lecture. The topic was bandwidth and signal to noise ratio trade-off. So the statement of the problem goes like this. A Gaussian channel has 1 megahertz bandwidth. Calculate the channel capacity if the signal power to noise spectral density ratio is 10 raised to power 5 hertz. Also find the maximum information rate. So to start with, we need to understand that there is a catch in this statement, that in the sense it mentions noise spectral density ratio, signal power to noise spectral density ratio. Now what is noise spectral density? In the lecture we have denoted this with eta, and when it is multiplied with the bandwidth, let's call this omega or W as bandwidth, which is given in the question. This gives you the noise power n. So n is equal to eta into W. Now we are in a position to apply the formula for channel capacity as we have studied it in the last lecture. So the channel capacity C is given by bandwidth into log of 1 plus S upon N, which is the noise power. And we know from here that noise power is noise spectral density multiplied with the bandwidth. So now we can write it like this. S upon eta multiplied with the bandwidth. So everything is given in the question itself. We have 10 raised to power 6 hertz as bandwidth, and then we have 10 raised to power 5 hertz as the signal power, and that will be divided with 10 raised to power 6, and that will give us the answer in bits per second. Okay, so this is the answer for the first part. 13,800 bits per second is the channel capacity for that particular channel. Now, what is the maximum information rate? Let's come to the second part of the question. What is maximum information rate? And if you recall the previous discussion, the maximum information rate is given by when limit omega tends to infinity. When we put this limit on the channel capacity, we get the maximum information rate, and that is given by S upon eta log of E, which comes out to be 1.44 into S upon eta, and that's our max. That is the maximum information rate that we had derived in the last lecture. So going by this relation, the maximum information rate can be obtained as 1.44 into 10 raised to power 5, because this value 10 raised to power 5 hertz is the ratio of signal power to noise spectral density, and this answer will also come in terms of bits per second. So let's multiply it and we will get 144,000 bits per second. That was a straightforward application of the formula that we had derived in the last lecture, and this gives us the channel capacity for a given channel with some characteristics of signal power and noise spectral density, and also we are able to find maximum information rate from it.